All right, so today we're going to be looking at what is the sum of interior angles of a polygon. Now we're going to start this off with the polygon that we're most familiar with and the sum of its angles, and that is the triangle. Because we know what the angles in a triangle add up to be, because we've talked about it before. The angles in a triangle must add up to be 180 degrees. So for instance, here I have a triangle with an angle that I don't know. It's x. And I have a angle of 20 degrees here and then 80 degrees here. And the sum of these has to equal 180. So if I wanted to, I could say x plus 20 plus 80 equals 180 degrees. Of course, right? All right, well, if I simplify this expression, I would get x plus 100 has to equal 180. So some number plus 100 equals 180. We then know that x equals 80 degrees as well. So this would actually be an isosceles triangle, uh, an acute isosceles triangle. So, but anyway, we know this because the angles in a triangle have to equal 180 degrees. Well, what about for other polygons? So say a quadrilateral and a pentagon and so on and so forth. Well, I will show you the general formula and then I will show you where we get that from. Shall we? Let's begin. So first of all, it's very important for you to remember that the angles in a triangle equal 180 degrees when you add them all up. The interior angles of a triangle equal 180 degrees. That is very important to remember. Also remember that triangles are our basis for all other polygons. We can build any other polygon from triangles. And we can't have less than 3 sides. We must have 3 sides in order for it to be a polygon in the geometric space that we're dealing with in Euclidean geometry. So, with all of that said, I'm going to write a formula up here for you to find the sum of the interior angles for any n-gon or any polygon with n sides. So, for a polygon with n sides, the sum of the interior angles is 180 times the quantity of n minus 2. Okay? So what does that mean? That means if I want to know the sum of all the interior angles of a polygon, I just have to take the number of sides, subtract 2, and multiply that result by 180. Well, let's look at a triangle. A triangle has 3 sides. 3 minus 2, so I'll actually put up here. This is going to be for a triangle. Triangle has 3 sides, so this would be 180 times 3 minus 2. And 3 minus 2 is 1, and 1 times 180 is 180 degrees. So remember, order of operations, we would do parentheses first, and then we would simplify that, and then multiplication would come next in this case. So 180 times 1 will give us 180. Okay, what about a quadrilateral? So 180 times quantity 4 minus 2. Well, 4 minus 2 equals 2, and 2 times 180 is 360 degrees. So for a quadrilateral, or a fourgon, we would get 360 degrees as the sum of the interior angles. So if we add all the interior angles up, we would get 360 degrees. Well, let's see if that makes sense. So I'm going to draw just a quadrilateral up here. So it's four-sided polygon. And this is going to be a convex quadrilateral, meaning everything's pointed out. And off starters, you may say, okay, I kind of believe the 360 thing, because maybe you've seen a rectangle before and you know that the angles in it add up, or each 90 degrees, and they add up to 360. Or maybe you've seen a square and you know the same thing. But for any other quadrilateral, you may not be used to that. But maybe you can believe that very easily. Well, let me look at this another way. Remember, I said that we've seen earlier that any polygon can be split up into triangles, right? Well, let's split this up into the smallest number of triangles I can do. And that would be by taking a vertex and connecting it from just one vertex, connecting it to a vertex that it's not touching yet. So for instance, a diagonal in this case. So if I do that, I see that I clearly have 2 triangles, right? This triangle has 180 degrees in the interior. This triangle has 180 degrees in the interior. So in total, it's 360 degrees in the interior. Now I can, of course, split this up more and more. But if I were to do that, then I would notice that my interior angles would start to get split up more and more. And so it looks like I'm double using them. So I don't want to do that. So if I draw the smallest number of triangles I can to split up a polygon, I will clearly see that if I add 180 that many times, I will get the sum of the interior angles. So for a quadrilateral, if I split it once, I get two triangles, and what I end up having is that's 360 degrees. That's actually where this formula comes from, because the smallest number of triangles I can make will always be the number of sides minus 2. And so I take that, multiply times 180, because there are 180 degrees in a triangle, I'll end up with my sum of interior angles. Okay, maybe that's kind of easy to believe again with the quadrilateral. So let's look at it with the pentagon. So according to the formula we have here, a pentagon or a fivegon should be 180 times 5 minus 2. Well, 5 minus 2 is 3. 3 times 180 is 540 degrees. Okay, well, let's take a look at a pentagon here. And let's draw from just one vertex. Let's do from here, and we'll draw it to the vertexes that are not directly connected to it at this point. So from here, I'm going to go down. I'm going to go down here. And so I have 3 triangles, right? Each of those triangles has 180 degrees in it. So when I add that up, I end up with 540 degrees inside the triangle. Okay? So no matter what, for the sum of the interior angles, this will always be true for a polygon. If we take the number of triangles that we can create, the least amount of, each of those will be 180 degrees. We add them all up, we'll get our interior. Or another thing we can just do is remember this formula: 180 times the number of sides minus 2 every single time. Okay, cool. So no matter what it is, no matter how many sides it is, you can find out the sum of the interior angles for it. So let's get a little crazy. We'll jump real quick. Let's jump to, say, 102 gon. So a polygon with 102 sides. Why would you ever create one of those? I'm not sure. But if you had to find the sum of interior angles, you could. So 180 times 102 minus 2. Well, 102 minus 2 is 100 times 180. We end up with 18,000 degrees as the sum of the interior angles. All right, cool. You're probably thinking now, like, yeah, this is simple enough. Like, I can handle this, and you can. The sum of the interior angles will always just be 180 times the quantity of n minus 2, where n is the number of sides every single time. All right, so let's see how else we can use this information, shall we? So I'm going to erase here. I'll keep the statement up there about the sum of the interior angles. So using the sum, we can then analyze and figure out what is the measure of just one of the angles if they're all, say, the same. So if it was equal angular or regular, we could then know, based off the number of sides, what is the measure of each individual angle. Okay, so for example, let's say we have a regular say we have a regular 22 gon. Okay, and we want to find the measure of just one interior angle. What is the measurement of one interior angle? Okay, so the measurement of just one interior angle here. Well, let's find out what the sum of all of them is first. So we would do 180 times n minus 2, where n in this case is 22. And let's see, what do we end up getting here? So we get 180 times 20 So that would be 3,600. So 3,600 degrees is the sum of the interior angles. We took 180 minus n minus 2 times n minus 2. Where n was the number of sides. This is a 22 gong, so it is 22 in that case. 22 minus 2 is 20 times 180. We get 3,600. Okay, but we're still trying to find a measure of just one of those interior angles. This is the sum of all 22 of them. So how would I find a measure of just one of those angles? Well, what I would do in this case then is I would say, let's take 3,600, so 3,600, and let's divide by 22. And let's see what we end up getting. Well, in this case, we will get a fraction that we could reduce. We get 11 down here, and then we get 1,800 up top. Okay, and if you wanted to simplify that further, you could. And then we would see that the measure of each angle, we could divide these two numbers, would be approximately 163.63 repeating degrees. And that would be the measure of each interior angle. So just one interior angle would be 1,800 divided by 11 degrees, or approximately 163.63 repeating degrees. All right? So that would be the measure of one interior angle here. Well, that's kind of cool. Well, let's take this into another way. Okay, shall we? So I'm going to erase this here. Just this problem. So we use this to find the measure of an interior angle. Well, this time, let's say we are given an interior angle of a regular polygon is 108 degrees. 108 degrees. What is, or how many sides, or what type of polygon it is? Okay, so given an interior angle of a regular polygon is 180 degrees, so one of the angles is 180 degrees, and it's a regular polygon, meaning all the sides and angles are equal. What type of polygon is it? Okay, we name what type of polygon it is. Let's find out how to do this one. So we know from the get-go that we have 180 times n minus 2 will equal the sum of all the interior angles. Well, do we know the sum of them? No. But we do know that each one equals 108 degrees. So it will be 108 degrees times n, whatever n may be. We don't know yet, but we can definitely find out. Well, this looks like an algebra problem, right? This is solving for an unknown. Well, how did we do this in the past? Same way we're going to do it now. So first things first, we will simplify both sides of both expressions. So 180 can be distributed into the parentheses here. So we have 180 times n will give us 180n minus 180 times 2, which would be 360 degrees. Oops. All right. Now, if I wanted to, I could subtract the 108n on both sides. And I could also add the 360 on both sides. Okay. And if I were to do that, I will end up with 72n equals 360 degrees. And how would I find n at that point? That's right. I would divide both sides by 72. And I would actually end up seeing that n would have to be, once I divide both sides by 72, I end up with n is 5. In other words, this is a regular pentagon. Okay? So, based off the fact that we know this formula for the sum of the interior angles, and the fact we know one of the interior angles, in this case is 108, we can take 108 times n to find the total number of all the interior angles. We took the sum of all the interior angles. And we can say that equal to the formula. Once we do that, we just have to solve for n, and we can find out what the number of sides are. So those are three types of problems that you could be given in any scenario. Whenever you have to build something, or if you had to find the measurements of an angles and sides, say based off of a sketch, or if you were the one trying to design it, you can find out what the angles need to be from this. So if you wanted it to be regular, for instance. So we can use this information to find out what is the sum of the interior angles by just directly plugging in the number of sides. We can find out the measure of one interior angle if we know it's an equal angular or a regular polygon. And if we know it's an equal angular or regular polygon, we can find out how many sides we actually have given the measure of one of the interior angles. All right. So those are the three things we can do with this. Very powerful indeed. So we have talked about how to find the sum of interior angles for a polygon. We've seen where it comes from. So you have two ways to remember it: the formula directly, or how many triangles can you draw given a polygon from one vertex to all the other vertexes that is already not touching. Count how many 180-degree triangles you have inside and take the sum, and that would be the interior sum of the interior angles. Or you can just plug it into the formula here, whichever one you want to do. And you can use that to find out what is the sum of the interior angles. You can use that to find out if it's an equal angular or regular polygon, the measure of just one of them, one of the interior angles. And if you're given the measure of one of the interior angles, you can find out what type of polygon is it, if it's a regular or equal angular polygon. All right, that's sum of interior angles, and I will see you again soon.